Mercury is the first planet in our solar system, and at first sight, Mercury doesn't make sense. The harsh environment that the planet finds itself in may seem like it leaves no room for mysteries, but scientists have been attempting to uncover Mercury's secrets for years now. And here's what they've learned. Starting from the very basics, we're already beginning to see some oddities. Mercury's orbit around the Sun takes roughly 88 days due to its close proximity to it. However, this orbit is very unusual. It's often believed that Mercury is the hottest planet in our solar system because it's the closest. But this is not actually the case. Namely, Mercury hasn't got an atmosphere. The temperatures during the day can reach up to 430 degrees Celsius, but during the night these temperatures can plummet to as low as minus 170 degrees Celsius, giving Mercury the title of a planet with the biggest temperature shift of any known celestial body in our solar system. This peculiar orbit, as planetary scientist Nancy Chabot explains, results in Mercurian days being greatly different from days here on Earth. Mercury has to go around the Sun twice to have one complete day on the planet where the Sun goes from directly overhead to directly overhead, and this actually takes 176 Earth days. So, a hypothetical observer looking at the Sun from Mercury would see it rise and set twice during one Mercurian day. We've been wanting to carefully analyze Mercury for a very long time now. However, many missions never left their planning phase. The most successful mission was when NASA's Jet Propulsion Laboratory launched the Messenger on the 3rd of August 2004. Before Messenger, we only knew about 45% of the planet. But this probe helped us map out Mercury entirely. Naturally, there are still some shadow regions which are still completely mysterious to us, but overall we've got a pretty good idea of what's going on the surface. It's covered in craters, meaning that the planet is constantly getting bombarded with thousands of meteors without any significant planetary activity that would help in getting rid of those craters. Because of Mercury's rotational axis, which is close to 0 degrees, as well as the lack of an atmosphere, the temperature difference between the ground level and the craters is pretty shocking. Whereas the surface of Mercury is scorching, the craters never receive direct sunlight, which leaves them exposed to the freezing temperatures of space. And our Messenger spacecraft was able to confirm the presence of water ice in some of the researched craters. Now, the presence of ice was not the only surprise here though. By using the X-ray spectrometers to analyze certain elements on the surface of Mercury, scientists have found a large quantity of elements such as phosphorus, potassium and sulfur. The reason why this discovery is important is because our previous hypotheses claim that upon Mercury's formation, these lighter elements would remain on the surface, but will then be stripped away due to the planet's close proximity to the Sun, as well as the absence of an atmosphere. However, these elements remain in high amounts, much higher than previously anticipated. This little fact aside, the Messenger probes also confirmed that Mercury is the densest planet in our solar system. We found out that Mercury's got an enormous iron core, which takes up to 75% of the planet's radius. This is even bigger than the Earth's core, which only covers around 50% of our planet's radius. This iron core of Mercury's results in a bizarre magnetic field different to anything we've seen before, really. Mercury is one of 4 rocky planets in our solar system, and even though it's the closest planet to the Sun now, it's believed that many thousands of years ago it was much further away. Maybe even further than Mars. It's believed that Mercury too had its moment in the Sun briefly, where lighter, previously mentioned elements could have formed rocks which would not be vaporized by the Sun. Maybe it also had the ability to have an atmosphere of its own, an atmosphere which would maybe allow liquid water and perhaps many other components required for life to form to exist for a little while, before everything was stripped away. Perhaps changes like these are pretty common in space. In our eyes, it's difficult to imagine big changes in our solar system. However, back during its early formation, the order of the planets differed greatly from what we've got here today. Our solar system was young, fiery and violent. So what exactly could have happened to Mercury? The answer to that question may lie in Mercury's massive iron core. We've already said that Mercury is the densest planet in our solar system. The fact that it's still geologically active with a magnetic field and a hot core goes against our knowledge of how the near-star planets should behave. It's likely that this unfortunate planet had a pretty difficult life. Back in the early days, it's likely that it found itself in the very middle of our dynamic young solar system. Back then, formation of an enormous celestial body like Jupiter would only bring destruction to everyone else. So it's possible that after such an event took place, the gravitational impact of this newly formed big object flung Mercury towards the Sun and also onto a collision course with another planet. Back then it was possible for planets to live briefly and then die. Therefore it's possible that Mercury crashed into another planet and ended up shattering completely. This event will then lead behind a small mysterious world that lost a vast majority of its outer layer and is now bound to one day be the first planet consumed by our Sun. Thank you very much for stopping by. Our next destination is Venus, so stay tuned for that one, and I'll see you in the next one.